Have you ever stopped to wonder what makes our world, well, move? I mean, think about it. From a little toy car to a powerful drill, it all comes down to this kind of elegant dance, a dance between two of the most basic forces of nature. So today, we're going to pull back that curtain and see exactly how these little motors turn simple electricity into motion. Okay, so let's start with a little riddle. What do a kid's toy, a table fan, and an electric toothbrush all have in common? I mean, they look totally different, right? But deep down, they all share the exact same secret, a small, powerful engine that runs on a principle we're just about to unpack. So, if we want to understand how a motor works, we first got to get a handle on two key forces of nature. Let's just start with the absolute basics of what makes things, spin. All right, first up, electricity. And the number one rule of electricity is that for it to do anything, it needs a complete, unbroken loop to travel through. We call that a circuit. So the power flows from the battery, through the wires, and right back again. If you break that path anywhere, poof, the flow stops, no flow, no power. Simple as that. Okay, now check this out. What happens if we just flip the battery around? The direction of that electrical flow totally reverses. Now, this seems super simple, right? But this idea, the ability to reverse the current, is the absolute key to making a motor work. Seriously, tuck this idea away because we're going to need it in a minute. Okay, so that's force number one, electricity. Now for force number two, magnetism. And you know what? The rules for magnets are super simple, super predictable. Every magnet has a north and a south pole. Opposites attract. And the same poles, well, they push each other away. That's it. That's the whole rule book. So let's take that rule book and actually make something happen. What if we put one magnet on an axle so it can spin freely, and then we bring another magnet nearby? Well, that natural push and pull is going to force it to spin around until its opposite poles line up. And just like that, we've turned this invisible magnetic force into real physical motion. Pretty cool, right? All right, so we've got our two key ingredients, right? We've got this controllable flow of electricity, and we've got the push and pull of magnets. Now comes the really fun part. Let's see what happens when we mix them together. And this is where things get really cool. It turns out you can actually create a magnet just by using electricity. I mean, think about this. You take a normal piece of metal, like a bolt, wrap it in some wire, and then connect a battery. The electricity flowing through that wire forces all the little magnetic bits inside the metal to line up, and bam! Instantly, you have a magnet. We call this an electromagnet. So why is this electromagnet the star of our show? Well, look at the difference. A regular permanent magnet, it's always on, its poles are stuck. But an electromagnet has two incredible superpowers. One, you can turn it on and off with a switch. And two, remember that trick with flipping the battery? You can instantly flip its north and south poles. This level of control, it changes everything. Okay, so now we have a magnet we can completely control. We can turn it on, turn it off, and flip its poles whenever we want. And that control, right there, is the whole secret to creating continuous spinning motion. Let's see how it works. So let's build a really basic motor. We're going to take our controllable electromagnet, put it on an axle, and stick it right between two permanent magnets. Now, when we turn on the power, what happens? The same old forces of attraction and repulsion kick in, and our electromagnet starts to spin, trying to line itself up. And then it just stops. See? We've hit a snag. Once those opposite poles are lined up, the forces are perfectly balanced. All that pushing and pulling just cancels itself out, and the spin just dies. We get a half turn of motion, and that's it. We're stuck. And this, right here, is the central puzzle we have to solve. A single half turn isn't going to power a fan, right? So the big question is, how do we break that magnetic deadlock? How do we trick the magnet into chasing that alignment forever to create a nonstop spin? Well, the solution is this really clever little device called a commutator, and you can just think of it as a smart rotating switch. It's an amazing piece of engineering. This little ring spins right along with our electromagnet, and its entire job is to automatically flip the electricity at the perfect moment every single time. So here's how this magic happens. Power flows from these little stationary things called brushes into the commutator ring, and that creates the magnetic field that starts the spin. But watch, just as it's about to lock into place, the ring has rotated just enough that the brushes hit these little gaps and make contact with the opposite side of the ring, and that, in an instant, reverses the electrical current, flipping the electromagnet's poles. So now, the end that was being pulled in is suddenly being pushed away, forcing the spin to keep going. It's this constant game of push me, pull you, timed absolutely perfectly. So yeah, that commutator, that's really the heart of a simple DC motor. But to make it actually useful in the real world, to power things, we need to make a couple of key improvements to get more power and a much smoother spin. Okay, time for a little bit of official lingo. The stationary part on the outside, the permanent magnets, that's called the stator, because it's static, it doesn't move. The whole spinning thing in the middle, that's the rotor, because it rotates. Stator is static, rotor rotates. Easy to remember, right? Now, there's a problem with our simple one-loop setup. The power it delivers is kind of jerky. And even worse, it could get stuck in just the right spot where the brushes aren't touching anything, and the motor just won't start. Yeah, not very reliable. But the solution is actually beautifully simple. Just add more loops. A real motor has a bunch of electromagnets arranged around the center. As the rotor spins, the commutator energizes each one in sequence, so they're kind of firing one after another. It's like they're handing off the work, which means there's always a pushing or pulling force, and that gives you a perfectly smooth, continuous spin. So what if you want more power? More oomph, more speed? Well, there are two really simple ways to do it. You can either wrap a lot more wire around each loop, or you can just crank up the electricity from the power source. Both of those things make the electromagnet stronger, which means a stronger push and a faster, more powerful spin. And that spinning motion, that's what this is all about. We call that torque. And that rotation is what we harness to power everything, from the fan that cools you down to the blades on an electric knife. It all comes back to that one simple, continuous spin we just built. So the next time you see something battery-powered start to move, you'll know the secret hiding inside. It's just a constant, perfectly timed dance of attraction and repulsion between magnets. This incredibly simple idea already powers so much of our world. It kind of makes you wonder, right? What's it going to power next?